The topic of this video is identifying the turning points and end behavior of a polynomial function. Let's look at a problem. For f of x equals 5, parenthesis, x squared plus 9, close parenthesis, open parenthesis, x minus 4, close parenthesis, cubed. Part C, determine the degree and maximum number of turning points. Part D, determine the end behavior. Alright, we'll begin with Part C, determine the degree and the maximum number of turning points. There are two ways to determine the degree of a polynomial. Depends on the form of the polynomial. This polynomial is in factored form, but a polynomial could also be written in standard form. When your polynomial is in standard form, the first term, the one with the highest exponent of x, is going to determine the degree. However, when in factored form like this problem, the degree is determined using the theorem that was stated in a previous video. Let's do that now. We're going to rewrite our function f of x in expanded factored form. So this would be 5 times the factor x squared plus 9 times the factor x minus 4 times the factor x minus 4 times the factor x minus 4. Because x minus 4 was being raised to the third power, that a factor appears 3 times. Now, each one of these 5 factors is a polynomial. It meets the definition. We'll label this. So according to the theorem, if all of the factors are polynomials, then your function is a polynomial. Its degree comes from adding the degrees of the individual polynomials that were being multiplied. So let's identify the degree of each one of our polynomials. The degree is 0, 2, 1, 1, 1. When we add all of these together, it gives us the degree of f of x. 0 plus 2 plus 1 plus 1 plus 1 equals 5. So f of x is a polynomial of degree 5. Once we know the degree, we can determine the maximum number of turning points using the math elevator. We'll put the D car on the 5th floor, and we'll remind ourselves that d over t determines the location of both cars relative to each other. So, d over t. T could be in any one of these positions. So therefore, what is the maximum that it could be? The answer is 4. So, the maximum number of turning points is 4. Okay, this moves us on to part D, determine the end behavior. End behavior can be calculated in two ways, and it depends on the form of the polynomial. If your polynomial is in factored form like it is for this problem, then the end behavior will be found by using the leading coefficient and a power of x equal to the degree of the polynomial. If, however, your polynomial is in standard form, the end behavior would be found by multiplying all of the factors and using the highest degree term, the leading term. That's a lot of work. So for this particular problem, we are going to use the fact that our polynomial is given to us in factored form to write its equation. The equation will be y equals the leading coefficient, which in this case is 5, multiplied by a power of x whose exponent is equal to the degree of the polynomial, which in this case, coincidentally, is also 5. So our end behavior is y equals 5x to the 5th. If you were to graph the function f of x and the function y equals 5x to the 5th and looked at both graphs very far from the origin, they would look nearly identical.